Okay, guys, so we are going to do chapter 2, section 4, last section of this chapter. So then we're going to do a review and then your test. So here we go. Chapter 2, section 4 is representing data. Be sure that your book or ebook is open to page 55. If you're using your workbook, that's page 25. But remember, guys, you don't have to use the workbook. I recommend it because there's a lot of good practice in there, and it's got like your vocab laid out and everything. But I highly suggest that you at least take notes on paper. You're going to want them. All right, moving on. So let me get started. Here we go. If I'm talking about all this data that I have collected and I know how to do math with and I can count the digits for based on my whatever tool that I'm using for it, I can also take that data and put it into a representation. Let's go representation. So the first thing I want you to do is think, what do you know about how we represent data? This is the wrong section. Give me 1 second. Struggle bus, guys. All right, trying again. Section 4, representing data. Main idea here, graphs visually depict data, which makes it easier to see patterns and trends. What do you know about graphs? What do you know about graphing data? How can you find a pattern and trend? What else do you want to know? And please come back and think about what you learned. And guys, that is important because it's what we call metacognition. And the idea of asking yourself, what do I know? And then coming back and saying, oh, wait, now I know this much more is very good for learning. So let's move forward. Essential questions. Why are graphs created? You're like, because you told me to. Please don't say that. We use graphs for a very specific reason. And then we're going to talk about how they can be interpreted. Review vocabulary. Independent variable is the variable that is changed during an experiment. So we already have beat that like a dead horse. I will continue for a little while until we do our first couple of labs so that you are clearly aware of which one you're manipulating and which one you're tracking. New definition you'll need to look for is graph. And here it is. So I need you to have the definition of graph. Struggle bus. So here, if I'm talking about a graph, I'm talking about a visual display of data that makes trends easier to see than in a table. Tables are great, but I can't easily notice what values are doing compared to each other unless I put it in a graph. So tables, fabulous. I can read this, I can tell what's going on. And then over here on the right, I can tell what's happening in this pie chart. That's like the parts of a whole. So I can kind of see what's happening here. The values on the left in the table tell me sources of chlorine in the stratosphere. And then it gives me all of these different compounds. Notice those CFCs at the bottom. But then if I look at it in a pie chart, there's a big difference in how I can notice that information. So keep that in mind that this pie chart shows the same information as the table over here. It's just easier to see. Notice they also break it down into manufactured compounds, so compounds that we have made, like synthetic compounds, and then the natural sources of chlorine in that stratosphere that are breaking down that ozone as it interacts. So, big problem here, we're making all of this stuff. Let's see. Another good way to show a graph is by using a bar graph. They're often used to show quantities varying across categories. So you're not going to use a bar graph unless you're showing category stuff that can't be plotted across like a line graph. So here, if I'm looking at the magnesium content in a bunch of different things, I'm going to show it in a bar graph to show those relative to each other. Obviously, halibut has the most, all the way down to raisins have the least amount of magnesium. And remember, magnesium is an element on the periodic table. So all of these foods, when you're ingesting them, you're getting that it's actually a metal, but you're getting it in an ion form, which helps interact with other parts of your body. All right, moving on. My favorite. In line graphs, your independent variables are on the x-axis. So on your bell work, I kind of asked you a cheat question because you didn't know this yet, but now you do. So independent is always on the x-axis. Independent x, independent x. Dependent is always on the y-axis. Dependent y, dependent y. And usually you'll figure out why, but just kidding. So here I can see that as my volume increases, so does my mass. Those have what we call a direct relationship. As one increases, the other increases. So when we're looking at these, we can plot points and we can use those points to figure out, well, at this point B, my volume was 20 centimeters cubed and my mass was 54. So I can divide those two and get my density. Same here at C. I don't have the numbers written out, but I could take my mass and I could divide by my volume. Here at part A, my mass is 27 and my volume is 10. So I would divide the two and get 2.7. Every time you divide them, you're going to get 2.7. That's what lets me know it's a direct relationship. Over here on the right, as elevation increases, temperature does what? Temperature decreases. So this is what we call an inverse relationship. As one goes up, the other goes down. So if they're doing the same, one goes up, the other goes up, those are direct relationships. As one goes up, the other goes down, that is called an inverse relationship. So when we're using that line graph, something important to keep in mind is the slope, the rise over the run. What is the change in the y value divided by the change in the x value? So you just pick 2 points, whatever they may be, subtract them, the y from the y and the x from the x, and you'll get that slope. If the slope is positive, it's direct. If it's negative, it's inverse. Now, these are a couple of things that we're definitely going to practice on in our ACT prep, which that'll probably just work into bell work because I really don't know how to do that for distance learning, but I'll figure it out. We'll start that soon. Anyhow, so here, interpolation and extrapolation are huge on the ACT. They're going to give you a set of data, like in a table or in a graph, or could be a bar chart or bar graph. I don't know how that would work, but we'll figure it out. And they're going to ask you to interpolate. When you interpolate between two, I don't know if it's going to work. When you interpolate between 2 points, you're picking something on there and you're estimating values that fall between points on the graph. So here I might have values here and here, and then I might ask you what this number is. If I'm doing extrapolation, it's extra, it's outside. It's estimating values outside the points by extending the line. That would be like asking you something on this end or something on this end of the graph. Normally there has to be a very good trend there for you to see that. So here, this graph down here at the bottom is showing me ozone measurements at Halley, don't know where that is, over a certain month's period. So when we're looking at it, if you notice the total ozone versus the time, the 1957 to 1972 were the red line, 99 to 2000 were in the green lines. So see, it was much higher and now it's much lower over time. And if you notice, those numbers drop as the cold months occur for the green, but they seem to rise in the previous time. So that's important to know. I can't seem to get this to turn off. There it goes. All right. That's pretty much it on graphing. We're going to do a lot more practice. I'm going to have you do a lot of work for the ACT practice, but remember, why are they created? What was the point? And how can we interpret them? All right, guys, it's a short video today. I know you're excited. Please be sure that you do the activity that goes with this, if there is one. So just check out online and make sure you know what you're doing. Email me with any questions.